Excuse me. Okay, let's go ahead and read. As you've learned, given a balanced chemical equation and the mass of one of the substances in a reaction, the mass of any other substance in a reaction can be calculated. We did that before, didn't we? Okay, next. Calculations in this way is known, in which a known mass is used to find the unknown mass in a chemical reaction is called a mass-mass calculation. I didn't really care too much about the name of it. It just means I give you mass. Can you tell me the mass of the other one? I don't really care. They call it a mass-mass calculation. In this experiment, a double replacement reaction will occur when an aqueous solution of lead 2 nitrate is mixed with an aqueous solution of potassium iodide. There are 2 products of this reaction. One of them is an insoluble solid, and which will precipitate out. The other one is a soluble salt, which will remain in solution. The insoluble salt will be separated from the liquid, dried, and its mass determined. The value of the experimentally measured mass, also known as the, what's this called? What would be another name for that? What's another name for the experimentally measured mass? That's one of the vocabulary words last chapter. Not if I actually do it. If with experimentally measured mass means when you do the experiment, what you get. That's the actual yield, isn't it? And what you're going to do is will be compared to the theoretical mass of the compound predicted by the mass-mass calculations. This experiment should further emphasize the importance of these calculations. Now, I can tell you right now that if you look at the top, if you look at the first thing we're going to do, we all definitely have to have goggles on because we have chemicals. We aren't going to be doing any heating on this experiment. No heating, but we are going to be having a chemical reaction take place. Now, let's take a look at the procedure. It says, using a balance, measure out exactly 3.31 grams of lead 2 nitrate and record this mass in your data table. And then it says, place the lead nitrate into a 250 milliliter beaker and add 50 milliliters of water. Okay, now write a little note to yourself. We're going to use distilled water, okay? So I'll go out and buy some distilled water because tap water has things in it that might mess up our numbers. So I'll get some distilled water, and so write a little note to yourself, distilled water. And also I'll tell you that, do you notice that they said approximately 50 grams or 50 milliliters of water? You know what does that mean? How exact should you be on that one? What do you think? Are you gonna take 5 minutes and measure out exactly 50 milliliters of water? You don't have to. Now, what about the 3.31 though? That has to be exact. Now, 50 simply means there's going to be enough water to dissolve it. So it's okay if it's 49. It's okay if it's 52. You get that? But just be about 50. So if you wanted to, you could use those lines on the beaker. They're not very accurate, but I could get around 50, can't I? So you could do that. Now you're going to, here's where the problem comes in. You want to try to get 100% yield, don't you? What kind of things might go wrong? Are you going to purposely try to not measure 3.31 grams? I think you're going to do a good job on that. Get that? And this is not going to matter. If it's about 50 milliliters of water, you're going to be okay. That's not going to mess you up. But I want you to think about this. What are you going to do when you stir those together with a stirring rod? Now what are you going to do? What are you going to do? You're going to lay it on the table? Why would you not want to do that? You're going to lose some of the chemicals. So what are you going to do to fix that? I'm trying to get you to maximize your yield, okay? You can't stir something and lay it on the table. What if I stir it and lay it on a paper towel? That's no good. So what can I do? Any ideas? Any ideas? All right, you'll also have a wash bottle, okay? Now, what am I going to do with the wash bottle, you think? Stir it. What can I do? Squirt, squirt, squirt. Not a lot. Little bits of water. Stir your stirring rod off. And that stuff goes back into the beaker, doesn't it? Then I can lay it on paper towel if I want. Okay, then what? It says here, make sure that all the crystals are dissolved. Rinse off the stirring rod. Now, that doesn't mean rinse it off in the sink. Rinse it off in your beaker. So make a little note. Rinse it off in the beaker. Now, measure out. I'd like that to be as exact as you can. I'd like it to be exact as you can. Say 3.50 grams of potassium iodide. Put that in a clean 100 milliliter beaker and add 50 milliliters of water. Stir. Do the same thing you did. Rinse off, that kind of stuff there. Why do they want a 250 milliliter beaker for one of them and a 100 milliliter beaker on the other? What do you think the next step's going to be? What do you see yourself doing? I've got this beaker of one chemical that's dissolved in water. As a matter of fact, it looks like water. I have another chemical, it's dissolved, and it looks like water. What am I going to do with these two beakers? Let's look at the next step. Pour the Ki solution into the 250 milliliter containing the lead nitrate. Do you understand why that beaker had to be bigger? Are you with me or not? You got 250 milliliter, 100 milliliter. I don't want to pour the 250 into that one, and I'll run out of space, won't I? But I can pour it this way, and I'll have a nice big beaker where they can react. And they are going to react in there, okay? But wait a minute. I want to maximize my yield. What happens when I pour the one beaker into the other one? What are you going to do then? See, if you can see yourself doing this, you'll know how this lab works. I've just poured one beaker into another. Would I just set the beaker down? Is that it? What would I do? See that? Wouldn't I do that? Wouldn't I try to rinse that one and put it in there? Got it? Now, I will tell you that you could rinse with as much water as you want, but the more water you have in that beaker, the longer it takes to filter. You get that? So we're not trying to douse it with huge amounts of water because you'll be here for an hour filtering it. You guys have a good game, have a good match.
Thank you.
Where's I at? Okay. Now you've got this beaker and it's going to have a precipitate in it. And you said, you know what I need to do? I need to find out how much that precipitate weighs. But it's all wet and it's mixed with water. How in the world, what am I going to do about that? How are you going to separate the precipitate from all that other stuff in there? What do you think? I know it's Monday, you haven't been to school for 10 days, but what do you see yourself doing with that beaker that has a precipitate in it? What is it? Filter it. Now take a look at the picture. You can set up an apparatus. Instead of a ring stand, we use these. We did this before, didn't we? Did you guys set up an apparatus? Have you set up any apparatus yet? Oh, okay. Anyway, way back there in the back, underneath all those globes, that's the shelf that has all the poles in it. Now, there are two kinds of poles back there. One is a regular pole, and both ends look like a hot dog. And then one of the poles, one type of pole is tapered. Does everybody know what tapered means? Okay, it starts out as one diameter and it gets smaller. Okay, if you put a tapered pole in that hole, it'll stay in there. It'll be wedged in there. You get that? And then I'll have some rings. See the rings? I'll have some rings out there. And I'll also have some funnels. I'll have stirring rods. And you have beakers. I have all the beakers right there. All the beakers you need are right there. All right, now, here's the critical step. I've got this beaker full of precipitate, and all I need to do is separate the precipitate from everything else, and then I'll be on my way. So what do you see yourself doing? I say, well, I'm going to put that pole in there. I'm going to go get the ring. As a matter of fact, the ring, I forgot to tell you that, the ring has to have another little attachment here. You'll see it. And anyway, you're going to put that in there. Then you can put a piece of filter paper. And you said, filter paper? I don't know what filter paper is. All right, so let me show you what that looks like. into a funnel. What's the directions say? What's it say about, does it say anything about how to do that? It says, wait a minute, before I do anything, what's number 5 say? Matter of fact, this is actually one of the most important things you have to do. Put a little star there, number 5. What do you have to do? Find the mass of the filter paper. How do I do that? Oh, wait, aren't I? Now, you have to know this. You have to know the mass of this guy. You got that? Because later it's going to be wet. And later there's going to be stuff sticking to it, and I won't be able to get it off. So I have to know this mass. So put a star there. And anyway, write that down, and it'll go to hundredths of a gram. So make sure you do that. If you don't do that, you'll have to start all over on some other time, okay? All right, so now I weighed it, and now how do I get it into a funnel? And so what you do is you fold it once, and it looks like a taco. Yeah? Like a taco? Okay, you're not done yet. So you fold it twice. Now don't use your fingernails to crease it. See that? I'm not creasing it heavily. I'm just creasing a little bit. If you go like that, you'll tear holes in it, and everything will come through. So I just kind of fold it like that, and this is where you have to be smarter than the filter paper. Is this going to work? No. What if I just pull? Will that work? Okay. So now, what I have this in, and I have this in a filter, a funnel. What is it? Right down there in that bottom drawer. Give me a nice small. I found Miss Fowles using funnels today, so I'm not doing mine until. Give us, what's the small one? Give us a small one. Check the next one. Check the next one. Any smaller than that. Ooh, she has all the small ones. Pick the smallest funnel you can find. Okay. Thank you. All right. We will have smaller funnels in this. I think she's using them right now. Okay, so here, you put it in here and say, all right, I'm ready. Whoop, whoop. Oh. Okay, so how do we fix that problem? It says here, find the mass of the filter paper, record this mass, fold the filter paper, place it in the funnel as shown. Now, a little technique that you need to know is in order to get this to stick to the funnel, you take your wash bottle, and you wet it. See that? Now if you wet it, it'll stick to the sides and you'll be ready to go. You ready on that? So you write that little note in there. You're going to wet the filter paper with the wash bottle. And everything's distilled water, okay? All right, what's the next step? Pour the mixture from the 250 milliliter beaker into the funnel as shown and pour slowly. Now, what's a general rule? How far should I fill a filter paper? If you fill it to the top, what might happen? If you go to the very top, what might happen? Yeah, the chemicals could get behind it, couldn't it? And then they won't be filtered, right? So I would say I would not go more than maybe 3/4, maybe 80% of the way up to filter paper. Get that? And you gotta be patient. You gotta be patient because when you pour it in there like that, you gotta wait, and it's gonna drip. Everything that is dissolved in the water will go through here. If it's insoluble, it'll stay here, won't it? And that's what I want. And then you just wait, and then you pour again, pour again. Now, one thing I would suggest is if you keep stirring your beaker and then doing it, then a lot of stuff will come out. If you just pour it, you have a lot of precipitate left, and you have to add more water to it. You don't want to do that. Now, I know what you're going to forget, because I think I would if I was your age. Every time you stir that beaker, what's on that stirring rod? Chemicals. Every time you do that, you have to rinse it off a little bit, don't you? Okay, so now, I do that, I pour it, I wait, and then I have a trash beaker, don't I? See the trash beaker down there? Okay, I don't want to go over the table, so I have a trash beaker, and I don't really want that. I don't really want what's in a trash beaker. I want that stuff there, don't I? All right, so the next one, it says, rinse the beaker with about 20 milliliters of water, and what's going to happen with this beaker? You're going to have everything poured out, and there's still going to be precipitate sticking to the sides. Now what do you do? Because you're trying to get 100% yield, aren't you? What do you see yourself doing there? What if you were a cook and you want to get every bit of that? And cook, you might have a spatula at home, right? And I have those. I have metal spatulas. We can do that. Or I could use stirring rods. And so what you could do is take the stirring rod, try to get it off the side, and squirt, 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 squirt. Again, the more water you use, the longer it takes to filter, doesn't it? Now, some of you are going to be so good at getting that off the sides, when it gets done, your beaker's going to look very clean. Some of you are going to have yellow stuff all over it. And it said, I tried. I just don't have patience for this. And then your percent yield won't be as high. Anyway, I know you're thinking, how come I won't get 100% yield? You'll find out. You'll find out. All right, what's next? Now, another thing you should do, when everything's out and the precipitate's sitting right here, why should you rinse it again with distilled water? Why should you go ahead and rinse it again with some distilled water if you have time? Maybe I have an idea. Take a look at the first two chemicals we're using. We're going to mix lead 2 nitrate, which is soluble, and we're going to mix it with what? What's the second chemical? Lead 2 nitrate and potassium iodide, is that right? Okay, now what are the two products going to be? It's double replacement. What are the two products going to be? Help me out. Lead 2 nitrate and potassium iodide. What are the two products going to be? Jonathan, you know.
Lead, iodide.
Yes, lead 2 iodide. Potassium what?
Nitrate.
Okay. Everybody okay? Now, of those two products, which of those two products are going to be stuck in the filter paper? Which one's going to be the precipitate? Do I remember? All nitrates are, I know, you haven't been in school for a while. All nitrates are what? You know. All nitrates are what? Soluble. What does that mean? They're going to dissolve in water, right? It's going to go right through that filter paper, right down. But what if some of that stuff is still stuck in water and is stuck in your precipitate? You want to rinse it again with some plain water to hope more and more of it will come out of your precipitate, and then you'll get a better percent yield here. You should not get 100%, number one, and you definitely should not get over 100% yield. But if you do get over 100% yield, it's possible you have another chemical in there that you didn't rinse it out. And that's why you wondered how to get over 100%. Okay, and then it says, wash the precipitate by pouring about 10 milliliters of clean water, that's again distilled water, through the filter. Remove the filter paper, and what we have to do is, here's the way that works best for me. These paper towel dispensers, I would say if you got about five pieces of paper towel, and then you folded them, that's 10 layers, get it? Then you carefully have to take this out, and what can happen, what bad things can happen when you're trying to pull this out? You could tear it, not good, but you'd be all right. What else could happen? You can get precipitate on your finger, can't you? So you have to figure out how to get that precipitate, how to get this filter paper out of there, and you want to stick it onto all those pieces of paper towel. And then, my suggestion would be carefully try to open up the filter paper so you get maximum drying. You get that? Now, we will not visit this lab again until probably Friday. It might be Friday. And by that time, if we do it on Wednesday, I might even wait till Monday. But I have to let it dry at least 2 days. I might let it dry over the weekend. And then when we get done, we'll stop, and I'll say, how do you know that was your filter paper? I'm going to put all these on a table. How do you know that was yours? So what should you do before you start here? What would you do? I put my initials on or something like that. With pencil, put your initials here and here and here, because it might be covered up with precipitate, right? And then when it's time to go get it, I'll bring the table out and you'll say, there's mine, that's ours. And then you're going to carefully go weigh it again, but you're gonna have the weight of the precipitate and the filter paper, aren't you? I don't want that. I only want the weight of the precipitate, so what do I have to do? Subtract the weight of the filter paper. Where did I get that? You better have done it in what? You better have done it in step 5. If you did not do step 5, you didn't weigh that out ahead of time, you gotta start all over again. Everybody got that? Okay, and what's the last thing it says? We don't have a drying oven here. It says place the weight filter paper on several layers of paper towel and allow it to dry. And then find the mass of the dry precipitate plus the filter paper, and then subtract the mass of the filter paper after drying has occurred. Okay, there we go. Now, matter of fact, this lab is different than the ones you've been doing. This is not a formal lab. The entire lab write-up is this page right here. The only thing I grade is this side right here. Get that? So you make sure you show all your work. What you're going to do today, before you leave, you're going to find a partner. And I think we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Ooh, that's great. We're going to have 4 groups of 3. All right, and then the golfers will be a group on their own. So that'll be 5 groups. I'll be okay with that. All right, so find it. Have groups of 3, and what you're going to do is the mass of the lead nitrate. I'm hoping that you have to try to make it exactly 3.31 grams. Okay, and then the mass of the filter paper, you won't know that yet. You won't know that yet till Wednesday. And then let's see where it says D. I would like you that when you do the reaction, I want you to make some observations and anything you notice about the whole lab. So try to make 2 or 3 observations where it says letter D. Okay, so that's what I'm looking for there. All right, what your group's going to do today is you're going to do number 1. You're going to find out what would the theoretical yield be for this chemical. Now, I'm assuming that you're going to use 3.31 grams of lead nitrate, and you're going to have 3.5 grams of potassium iodide. Now, what does that mean when I tell you the number of grams of each reactant? What do you have to do? You have 2 rows of boxes, aren't you? In that limiting reactant? And so what I want you to do here, see where it says calculations? I should see a balanced equation underneath there, and I should see 2 rows of boxes underneath it. You got that? I'll see grams above it, and 2 rows of boxes below it, and then you're going to try to figure out the theoretical yield. And then today, the last thing I want you to do is, I don't know how you would do it, a piece of paper, half a piece of paper. I want you to put your names on it, and I want you to tell me step by step, what are you going to do when you first come here on Wednesday, okay? And if it says number 1 says, Madeline's going to go get the goggles and set up the filtration apparatus. See that? And that's what I want. That's what I'm going to do today. I'm going to check it off today before you leave, and so you still have about 20-25 minutes. All right. Have any questions? All right. Find some people in a nice group. There'll be groups of 3, and then sit down. Try to figure out the balanced equation. Try to figure out the theoretical yield, and then make a step-by-step procedure. What are you going to see yourself doing on Wednesday? They're going to hand that in to me at the end of the period. So I need a step-by-step procedure. What are you going to do on Wednesday? What's step 1? What's step 2? What's step 3? Okay? So you guys, if you're not here today, you should think about what you're going to do. All right, that's all for today.